Dependent sources in simple circuits. When a dependent source is in a circuit, it adds an unknown variable to the solving process. As a result, the dependent source adds an unknown controlling variable like VC or IC in addition to the variable that you are asked to solve for. So when a dependent source appears in a circuit, two unknowns occur. So what you find here is that one of these, you have the variable, let's say X, that you want to solve for. And then two, the dependent source adds an unknown controlling variable, which we can define as the controlling voltage or the controlling current. So what this does here is that this requires setting up two equations for the two unknowns. Generally, one is forced to use a combination of KVL or KCL or both. So let's look at the problem solving strategy. So the first thing that you want to do here is that you want to apply simple circuit techniques to solve for the variable you want. Treat the dependent source as an independent source. In other words, like any other source. This process here sets up equation 1. What you're going to find here is that equation 1 now has one equation, but two unknown variables. The variable you want to solve for and the controlling voltage or current. 2. Apply the dependent source condition, which is typically called a DC, a dependent condition. Again, this is Carlos's language. Okay, it's Carlos's language, not anybody else's. So now, here we go. Locate the dependent source controlling element, of course, in the circuit, and see how it is defined. In this chapter, it's usually the current or voltage across a resistor. So if I have a resistor, and I have, let's say I could have some controlling voltage, VC, or I could have a current running through the resistor, which I call IC. Then what controls this element here is that VC is equal to R times IC. So in many cases, this is equation 2. However, in more challenging situations, the DC equation is derived either by KVL or KCL or both. And that would be equation 2. So now the third thing here is that now 1 has 2 equations and 2 unknowns that is used to solve for the wanted unknown variable x. Advice: / warning. In fact, I think I'm going to separate this. I'm going to put this down here. Do not add the controlling resistor into any equivalent resistances. By doing so, one loses all the information about the details of the controlling variable.